Okay, radical operations. So radicals, I like to think of them as working like variables. You can add like radicals, you can subtract like radicals, you can multiply radicals together if they do not have the same number underneath. This first problem, you're going to have to simplify our radicals in order to add them. So I like to copy my numbers on the outside because they're going to stay the same. I'll leave some room in between there. And then I'm going to break down 12. The biggest perfect square that goes into 12 is 4. And square root of 12 is 4 times 3. Square root of 4 is 2. And I'm going to need that square root of 3. If you want to keep going with that term, 2 times 2 is 4. Square root of 3. In that first term, 2 radical 12, we have delta. Similarly with 27, the biggest perfect square that goes into 27 is 9. And 27 is 9 times 3. The square root of 9 is 3. Square root of 3 does not break down. And so that term simplifies to 3 times 3 is 9, the square root of 3. So lots of little baby steps there to get to your final answer. 4 radical 3's minus 9 radical 3's is going to give us negative 5 radical 3's. For that problem number 13, you're just looking to get like radicals. Once you have like radicals, you're good. Then you can add or subtract. 14, we're going to FOIL. Square root of 5 times square root of 5 is square root of 5 squared. Square root of 5 times 3 is just that, 3 square root of 5. Negative 2 times square root of 5. And negative 2 times 3 is negative 6. Again, lots of baby steps in these. Square root of 5 squared is 5. Here I have 3 radical 5's minus 2 of them is just 1 radical of 5. Don't forget about that negative 6. And then my like terms are 5 and negative 6. So that's going to give me negative 1. So you could write that as negative 1 plus 1 radical 5 or negative 1 plus radical 5. Those are equivalent. All right, last one in the radical section. Here, in order to get rid of our radical in the denominator, we can't just multiply by, we can't just multiply by square root of 7 because we would have to distribute that into the denominator. So what we do is we use our fancy form of 1, just like we would on any other radical problem. We're going to copy down this denominator, 2 and radical 7, and we're going to switch the sign in the middle. Whatever we do to the bottom, we need to do to the top of our fraction. What that does is that turns the bottom of our fraction into a difference of squares. So we get rid of the middle terms that would have radicals embedded in them. In my numerator, radical 2 times 2 is 2 radical 2. Radical 2 times negative radical 7, so I'm going to do that in 2 steps. I'm going to have a negative 2 times 7 is square root of 14. Not the prettiest numerator I've ever seen, but the numerator isn't what we're working on rationalizing, it's the denominator. Now we're going to FOIL out the bottom. 2 times 2 is 4. 2 times negative square root of 7 is negative 2 square root of 7. Square root of 7 times 2 is positive 2 square root of 7. And then square root of 7 times square root of 7, careful with the sign, positive times a negative is negative. Square root of 7 times square root of 7 is 7. You could write it as square root of 7 squared like you did with the 5 on the last problem if you would like. Hey, our middle terms cancel. We made that happen on purpose because we wanted to get rid of our radicals. All right, last step here. The top stays the same. The denominator, 4 minus 7, is negative 3. So you can leave it like that. I don't really mind if you have negatives in the denominator. I don't know how picky your Algebra 2 teacher was about that. what we kind of do as you get into higher math is get a little bit less picky about those things, as long as you are doing the harder math well, as long as you have precision built in everywhere else. But if you want that negative out of the denominator, then you're going to switch the signs on the top as well. So that's the other way that you can see that, right? So if you're going to switch one sign, switch all the signs. All right, that's radical operations.